Okay, gang, for number 35, we're going to find the slope of this function at this point. So the first thing I want to do is take the derivative. This is chain rule. This is the outer layer. This is the inner layer. All right, so it's outie times innie. All right, derivative tangent is secant squared. That's a derivative of the tangent. Remember, once you take the derivative of a layer, it's like you can pretend it's gone. All right, now we're going to do times the derivative of the innie. So derivative of the innie is derivative of x is 1. You don't need this many brackets. Let me not overdo this. Derivative of x is 1. Derivative of y is dy dx. I'm just putting it in a square bracket because I don't want you to confuse, I don't want you to put anything into the trig. That's never, you can never change the inside of a trig without an identity. So that's why I'm just doing this so your eyes think that it's different stuff, because it is different parts. All right, so that's outie times innie, that takes care of that, is equal to 1. Now this just depends how you want to solve this. You want to isolate the dy dx, so I think some people will, you can either distribute the secant or you can divide it off. Now if you divide it off, like that, I suggest you use the identity here, right? 1 over secant squared would be the same thing as cosine squared, right? Because this is a reciprocal identity. So you could then rewrite this, right? 1 over secant squared is equal to cosine squared. That's an identity, reciprocal identity. All right, then you could move the 1 over. Okay, I feel like I know what some of you are thinking here. Let's take a look. Sine squared plus cosine squared equals to 1. So if you're going to do this identity, like that would mean you have to move the 1 to this side and you'd have to move the sine to this side, meaning like you'd get cosine squared x minus 1 equals 2. There's nothing wrong with writing it like that, but some people are going to misconstrue what I mean. So let me change the order. Math is so particular, and sometimes we sometimes can't see the little particularities until we stare at it long enough. So I'm going to actually put the minus 1 in front. And when you move the sign to the other side, it's negative. Okay, so if you're going to keep going with the identity, this is this. Right, this is just the idea of the template. You're working with an inner layer of x plus y, so you have to keep it like that. Now, you don't have to use any of these identities. You could be fiddling along with the secant, and that would be absolutely fine. I like this form. I'm going to plug in here. So you're sort of like the artist with the math. However you want to solve it, as long as it's legit, is fine. Some people will leave it like this, move the 1 to the other side, and then plug in like that. All right, I'm going to plug in here. So my x is 0, my y is 0. So now you're seeing me at the plug-in stage. Alright, so 0 plus 0 is obviously 0. Just make sure you're reading this correctly. This means this. You're plugging 0 into the sine function and you're squaring all of it. Now that's a quadrantal angle, so you should be on the unit circle right here at an angle of 0. And the sine is always the second value, so the sine of 0 is 0. So this is like 0 squared, negative 0 squared, which is 0. Okay, so the slope of the tangent line at this point is 0. So it's wherever it is on the graph, it's flat, right? It's touching it flat. It's a horizontal line because the slope is 0. All right, gang, that's it for this one. Catch you. Bye-bye.